So this is my NEO4J browser. I already have my COVID test and tracking database up and running. You know the file that Doc Eileen gave you, it has to be placed in a very specific location. So in my setup, I save the project in this dataset under import. So this is the file. It has to be under your import folder. So now we go to the practical side. So we're inching closer and closer to the workshop. So you've seen that we need data. And so one of the ways we can harness the data or collect the data is by talking to our telcos. They have the mobility data. Failing that, there are apps right now that Apple and Google are deploying. And locally in the Philippines, there are also several mobile app developers that are working on delivering a mobile app to help us collect contact tracing data. So very simply, the mobile contact tracing data would use Bluetooth. Whenever two people are close to each other, their cell phones will sense their Bluetooth in the range and they will exchange data. And after the exchange data, it will be saved to the cloud. And this is a representation of what the data would look like. So you should have the file with you by now. So this is the first person and this is the second person. They met on this date at this time in this location, and you have the longitude and latitude data. So if you scroll down, you should see a total of about 441 records. Here, we've added some more information about their activity. So like user 1, pH 92, and user 2, pH 93, were eating somewhere in Pedritos at this date and at this time. You will see that based on the dummy data, you don't actually, it's very hard to figure out a pattern. No? If you look at all this data, there's hardly any pattern here. But if we run this through our software, we should be able to generate insights that your local governments can use to help control COVID-19. In our chat window, you should see a command, a sequence of command that I typed there. You should type it on your input screen for NEO4J. So this one just merely says, load the file with headers. It's a file. This is the file name. This is the variable where you put it. And then we want to count everything. So this one gives us a count of how many records there are. So you should see 441 when you run it. You just click and then run. So now that we know there are 441 records, let's see. This next command shows us all the fields in that file. So again, we load the file. As of now, nothing is happening. We are just exploring the data. We are not yet loading the data into NEO4J. So when we click it, we're asking NEO4J to return the contents of one row. So these are the field names, and these are the value associated with all those field names. Okay, so this is just step by step. This is the actual command now to load the file into NEO4J. So here, let's go it line by line. We're reading from the file, and we're calling it a CSV row. So one record is one row. And we're using the command merge to create a person label that is uninfected. And we identify the user ID by the user 1. Ito yon, user 1 value will go into the user ID of this person. We're also creating user 2 as a node by using the user 2 row value and putting it inside user ID. So here we're just creating the actors, the people and the places. Here we're using merge. We can also use create. The nice thing about merge is if the value already exists in the database, merge will not create a second value. So this avoids the creation of duplicate values. So we're using merge. So here we're creating a label called place. We're naming it using the name place in this record. So place, the name is Eastgate Plaza. So this value will be assigned as the name property of the place node. All right. And once created, we set the command on create. We also add the latitude and the longitude to this place. So we can tag properties to the labels. So once we created the nodes, we will now create the links. Merge, all these commands are the same thing. We now run. So if we click here, we can see that we've created 117 persons, places, and relationship type is 1,821. So 4th Infantry Division, do you have the same results?
Medyo may ano kami, yung folder kung saan isi-save yung
Yeah. So look for where you installed NEO4J. So typically it should be in your Drive C My Programs.
Drive C. Yung kanina, users, my PC, etong NEO4J.
Yeah, NEO4J databases.
Okay. Tapos?
Double click there. Double click that one. That's your graph. Double click. Import. There. Import. There.
Okay. So
that
dito
is
ko
where
ilalagay.
diyan mo ilalagay. So, i-guide ko na lang kayo. Kayo ang maglagay. Yes.
Okay. It's there.
Okay, done. So now you go back to your NEO4J browser, not the desktop,
Browser.
Click mo yung My Project.
My project.
Okay, and then open. Click mo yung open na blue.
Open.
That should launch your NEO4J browser.
Okay.
There you go. Perfect. Go to our chat window.
Okay.
So, i-paste nyo lang po. Yan. So, if you click on the play button, it will launch the commands. There, that one. It should return 441 records.
That's
Yan.
it.
So, now you paste the second set of commands.
The same. Yan?
Yes, that one. Okay. So, now that is the first record. Okay. Now you copy. Did I paste the entire Okay. Let me now send you the commands to load the entire thing. Here is the command to now load the CSV into NEO4J. You just copy and paste. No more need for theory. That's the beauty. Copy and paste. It should be a several sets of line. Yes, correct. Okay, you can click run. So it will load 214 labels, created 117 nodes. And then you click on the upper disk icon. That should show you your database. If you click on that one, you should see database information, right? You can click it again to hide it. All right. Now I'm gonna give you eto na yung we're now starting on the exciting portions. I'm gonna type in the chat window the command you need to type in. So copy the command after the word first part and paste it on your window. Whenever you see a parenthesis, that's a node. Square brackets denote a relationship. So makikita mo, we're looking for a node that is somehow related to another node which is called place by a certain relationship. So because we did not specify the relationship, ang ibig sabihin nito, any relationship will match. And then you can see a directional arrow, right? So we're looking for people with any relationship going to that place. And then on the right side, we're looking for another set of person with any relationship going to the same place. And then we now have a matching or filter where we say that the first person must have a user ID of PH20 and the second person must have a user ID of PH91. And we want to show all the records where the place matches the word Dagupeñas. So Dagupeñas is a very famous restaurant in Dagupan. All right? So, sir, pakiclick nyo na yung play to execute the command. So there you go. So if you can open, this is the third record in the Excel spreadsheet. Now you can drag Dagupan, which is a red place, drag it down, okay, okay, yan. And then you can drag PH20 to your left, yan, and PH91 to your right. So take a moment to look at how NEO4J represents one record. In that one record, we have created 3 nodes, 2-person node, and 1 place na node. So the person nodes are separated by color. So you would see them in light blue. The labels are PH20 and PH91. Obviously, we expect the data to be anonymized. And only LGUs will have the association. For example, PH20 might have an associated record to a smartphone number, right? So only the LGUs will know to contact PH20 via an association record to a smartphone number. So notice the relationships are represented by lines, and there's a direction to their relationship. So PH20, if you can click near, sir, pakiclick mo yung near. Yan. You can see that as you click on a item, there are additional data on the bottom. So if you click near, you can see the action was eat, and the date was April 6, 2020, and the time was around noon. Right? Very good. Now, if you click a location, it shows you similar location, the location link first. Yeah. It shows you a similar information that tells us PH28 in the Dagupeña on this date and at this time. Now, if you click on the Dagupeña, yan, you will see that you have extra information. These are what we call properties that are associated with the node of place, which is the latitude and the longitude. The name is the Dagupeña. Now, you will see an icon to the bottom, go down a bit, that's expand or collapse. If you click that, please click. You will see all the people that also ate in the Dagupeña at that time. So please click the collapse button again. Yan. Okay? So that is the same technique that you can apply to PH91. If you click on PH91, you can also expand and see all the persons and people that this guy was recorded as visiting. Every other node you can click and drag to pull them away. So kindly select one. Yeah. Okay. Good. So now you can collapse it again. So this is a graphical way of representing the relationships. You can look at the left side, you will see an icon of a table. That relationship can also be represented in a table. It can also be represented as text. So click on text. Export CSV. So whatever the results of your Cipher query, you can export into CSV, and that is the data that your local governments will need. I will send you the next command. So please go to your Zoom chat window, copy and paste to the NEO4J the next set of commands. Here, what we want to do is, given two people, we would like to test if they were ever near each other. So as again, that's the pattern. We're looking for a pattern where one person is somehow related to another person. And we'd like to filter it to only records that match the first user's ID is PH20 and the second user's ID is PH91. And then we'd like to return the nodes N, which is the first person, and M, which is the second person. Please go ahead and click play. So now we have a confirmation that person 1 and person 2 were actually near each other. Can you click the graph output? There. So you can again click and drag the two nodes, click them far away from each other, far away. Okay. So these are the people. We now know that they are near each other. What is the problem with that? We know they are near each other. If you click near, we know the date and time. But we do not know where they met each other. Correct? So now what we need to do is we need to update our statement to change the pattern so that not only do we know that they actually met each other, we want to also know where they met each other. So you would see now, so now you will see that we have inserted a new pattern, which is the place in between the two people. We are still looking for the same set of people, but now we want to include a place. So if you now fire the command, we now see that PH10 and PH48 met each other at two places, Villaflor Hospital and Eastgate Plaza. Very intuitive. Again, for purposes of repetition, you can click on text to get the text output, and you can download it as a CSV if you wanted to. So please go to the download button, yes, and export CSV if you wanted to. So again, once you have the CSV, you can then open it on Excel or Star Office or Open Office, and your local government officials can then use the data to match it to the cell phone and call them up and say, you know, PH48, you were in Eastgate Plaza when you were infectious, and you came in contact with PH10. Now, a bit of a warning though, for legal purposes, you are not supposed to say that actually, right? So you should just say that you have infected some other people. And when you call up PH10, you are not supposed to tell them that it was PH48 that infected him. You should keep that information private. Okay, go back to the graph node. We will stop here for a moment and check on all our participants. Are you following? So can we proceed and ask the 4th Infantry Division? You are seeing the screens of the 4th Infantry Division. So now, where were we? We are asking the question, um, how did PH10 and PH48, two patients, meet up? We know when they meet up. We know what time. And this command here shows us the areas that they've been to, which is Villaflor Hospital and Eastgate Plaza. But there's a problem to this. If you take a look at location, click on the location, sir. Note mo yung time. PH10. Let's say PH10 ang naunang na-infect. Okay? What time did PH10 go to Villaflor? 6 o'clock. What time did they go to Eastgate Plaza? Can you click on the other location? Yes. 8 o'clock. Now go to PH48 and see what time they went to Villaflor and what time they went to Eastgate. So So here I am going to post another variation of the next command in the Zoom chat window that takes into account the time. We want to filter it to only the time when pH10 was there ahead of pH48. So kindly go to the chat window and paste the new variation of the command. Okay, before you run, now we are showing you that it is also able to filter based on properties of the links of the relationship. So R is the relationship where R went and did something to this place. We're now getting the date property of that link and comparing it to the date property of the second link. And now if you run the command, you will see that the other spot did not qualify. So there's only one spot now, one location. So they most likely met and got infected the other person at Villaflor Hospital. Now, the second question, of course, is your boss is going to ask, okay, if they were infected in Villaflor Hospital, who else was infected in Villaflor Hospital? And so this is a challenge to the 4th Infantry Division. What do you do? What do you click to expand the number of people that also visited Villaflor? There you go. So very simple. So you now know where they got infected and who else was infected in the same location. To those that are following us in the recording, these are all simulated. There is any similarities are just coincidence. The data file is a dummy file. It was generated in random, but the places we mentioned are actual places in Dagupan City. So can we ask the 4th Infantry Division to collapse the number of people again? So repetition, by just doing it again and again, we hope people can realize the power and the simplicity of the software. So let me now give you another case. I will type in the command. So here we are saying that any relationship from 1 to the 2nd degree, you match persons 1 to the 2nd person. Here we are looking for relationships between person 14 and person 53. So please click on the execute button. So please click person 53 and put him on the right side and person 14 on the left side. So you will now see all the 6 places that they both went to. So sa contact tracing, not only if we use this tool and that data set, not only do we know how one person infected the other, but we can also see the common areas that they went through so that we can forward the information to the local government for them to contact these establishments and ask them to do deep cleaning or institute social distancing or whatever, right? I will give you another instance. So for contact tracing, this is the most common command that you will want to enter. We want to find all the persons near the first person, and then you just substitute whoever you're looking for that is now confirmed positive, and return me the list of that person's contact. So if you then click on play, we can switch over to my screen na lang.
Yes. Kita
Okay.
na.
Okay. So let me then enter what they were supposed to enter. So this is the template of the command that the health officers will be using a lot. So here is the command where we are looking for one person and we want to look for everyone that came into contact with the first person. So that's just the command. So let's say the person we're looking for is PH14 and we want to see everybody that came in contact with him. So we just play and there you go. These are all the people that came in contact with PH14. And again, by process of repetition, we click on text and then we can export. And so this data will then go to your LGU and they can initiate contact tracing, contact, no? To let them know that they are probably exposed and they should probably get tested or isolate themselves. There you go. Now, something else, you can see here that these forms, that these 4 people form a tight-knit group. Most likely, these are family members or mahigpit na barkada ito based on the record of their mobility, of their contacts. So now we know who was in contact with PH14, but it doesn't include the place. So here is the command. I will also type it into our chat window so you can follow later. That will output including a place. So this is what we call multiple matches. So we match one statement, we match a second statement. So here we're looking at people that went to a place and also a second person that went to that was near that person. So here again, where is PH14? This is PH14, we drag it here. Everybody wants to follow. And these are all the people that were near PH14. And these are all the places they've been to. Now, in my version, you will notice that my links are different colors. I color-coded them for the activity. Like this one, the yellows are study. The light blue are travels. So we not only know who, when, and we also know what they did for each particular location. So now we go to the question of what if, like Ormoc, no? Ormoc is the highly urbanized and still 0 cases, no? So what the health officer can do is we don't wait for cases to crop up. We can be proactive and we can run a command like this where we are looking for people that are gala, no? They are the potential super spreaders. This is the command to identify the super spreaders in a particular community. So in this particular set of data, PH53, 99, and 23 are the people with a lot of interactions. So if they were infected, 53 would infect 14 other people. PH99 would infect 11 other people, and so on down the road. So if we gave this to your LGU and they have a 0 prevalence study or rapid COVID test, these are the people that you need to be tested first. Now, I have a graphic to explain the concept. No, please bear with me. So this is an example. So here is a representation of PH20 and PH1. So in this representation, PH20 has come into contact with all these places and all these persons. So in graph theory, this is one person that we say has a high degree centrality. So if this person were infected, here, he can infect this whole group here. And if this person were infected, he is probably able to infect this whole cluster here. That is the message behind computing the number of connections. Clear tayo so far?
Um, Wilson, this is
Yes.
Troy.
Yes,
I just
doctor.
have a question. Maybe
Mm-hmm.
generally, people would think that when we try to analyze or use this, um, siguro ang daming connections or contacts.
Mm-hmm.
But when we do um, social distancing and we limit yung movements of people, baka lumabas dyan mas
Konti.
less yung
Yes.
frequency ng contacts para mas doable, mas mabilis.
Correct.
At first, might be overwhelming siguro, pero once we try to limit yung movements ng tao, mas very clear yung kung sino yung mga connections or contacts ng tao. And
Yes.
that
Thank
will
you.
be
And
helpful for
ano,
us.
yes, Doc
Sorry.
Roy, that's a very important point kasi yung ano ko kasi yung I think there is a need now to refocus our energies kasi masyado tayong focused on testing na para bang hindi tayo makakapag-move kung wala tayong test. When in fact,
Yes.
ang sabi nga ni Dr. Troy, it's still social distancing that would really prevent the spread, the fast spread of the virus. So, if we can refocus ba, kasi parang, if we have to put into the context kasi, where are we in the pandemic curve? So, kung yung LGU mo is 0 ka or only have few cases versus nandun ka na sa maraming kaso, parang iba-iba siguro yung magiging approach natin, but at the core of it all is still isolation and social distancing. So I'm seeing great potential in this technology kasi ano talaga siya game changer siya, 'di ba, Doc Troy?
Oo. With testing kasi, we look for those who are infected, tapos those who might already have the antibodies kung rapid antibody test. Dito naman, parang bago magsimula yung gera, medyo
Alam mo
alam
na.
na natin kung sino yung susceptible or kung sino yung highly likely ang panggagalingan ng outbreak dito, yung sinasabi ni Sir Wilson na super spreader. Tuwan-tuwa nga ako kasi parang kung nakuha natin kung sino siya, we can try to give an advisory na to our local officials to limit the mobility, to have them tested. So parang targeted din tayo, pero proactive tayo. Instead of just for us to wait for cases na dumami at dumami. So uunahan natin ito kung sakali.
Thank you,
Yeah.
Dr. Troy, for the insight. Eto, dahil sa sinabi nyo, I'm reminded of one more thing, social distancing. How does an LGU know whether or not establishments are in fact implementing social distancing? So you can see here on my shared screen, I have a template that will show us the number of connections by place. So if, let's say, the mall did not implement social distancing, the mobile apps will pick up a lot of connections. Tama po ba?
Yes.
So
Bale, yes, Wilson. Kung alam natin kung maraming connections, bale, Sir Wilson, ibig sabihin
yes.
nun, yan yung malamang baka nahihirapan sa social distancing
Yes.
implementation.
Yes. Exactly. And remember that we captured the latitude and the longitude. So ngayon, we can export this as a CSV, and if you know a bit of Python, you can now create heat maps. This is just a sample, huh? So let's say this is a heat map of Samar. You now know where the people are congregating, and you can send your shock troops over to those areas to really enforce social distancing. So if you are armed with data, it's quite possible for an LGU to limit the lockdown to particular places. You do not have to lock down the entire city so that the rest of the city can restart their economic activity. Yan.
Yes. If I can also add in, Wilson,
Go ahead, sir.
in our case in Metro Manila, dito kasi may enhanced community quarantine tayo.
Mhm.
That will give us yung laging pinag-uusapan yung granularity hanggang
Exactly.
sa level ng location. If you, doon sa kanilang case, if we have super spreaders, ito naman yung mga places where they are most at risk siguro for possibly dun yung panggagalingan ng outbreak. In the past, dito sa Metro Manila, there were a lot of cases that were found connected to yung Green Hills Mall sa San Juan.
Yes.
We can find ito, Nepo Ball yata to, or maybe in Ormoc or in other places. It might be commercial centers, malls, schools. Kaya yun yung mga sinasara natin eh. I think dun sa South Korea, yung pinagalingan ng super spreader nila, yung church gathering na hundreds ba or maybe
Thousands.
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 Oo,
So
yung
that's the reason
pinagalingan nila.
why.
Oo.
Tama kayo,
Eh,
Dr.
yeah.
So
And
this
now in
data,
South Korea, sorry. And
Go ahead, go
now
ahead.
in South Korea, they are using this kind of technology to notify people of what areas they should be avoiding. So, I think proactively, ang ginagawa ng mga authorities nila, working with our national authorities then, is that they send out messages to people to avoid places kung ito na nga, may shock troop sign dumating and they were able to verify na talagang mahirap yung social distancing sa lugar. Might as well try to avoid these places na. Anyway, thanks, Wilson.
Yes. And you're right. By sharing the information, like in Singapore here, the government puts out a lot of tarpaulins to say this area has a red alert for dengue. So everybody that's in that area knows to take proper precautions. So parang ganun din ang gagawin natin. Armed with data, we can do this. Now, ito po ang isang magandang template. I urge you to take note of this following template. This is a case of we have two, in this scenario, PH98 and PH10 are both infected. We know that PH10 infected PH98, but there is no known clear direct links. These two people do not know each other. So how did PH10 infect PH98? By using this template command, we can show the series of infection that took place between PH98. So this one, 98, infected 76, who then infected 48, who then infected 64, who then infected 35, and finally reaching PH10. We now know, what do you call that in epidemiology? Yung from patient 0 to if PH98 is patient 0, you see the chain of infections. Because of this data, we can trace. I do not know what they call this process.
It's called a chain of transmission. Bale,
okay.
Kung one to another. And that's what we want to identify, and hopefully yan yung ma-prevent natin from yung mag-lengthen pa, dadami pa sila. And each part of the chain of transmission, kanya-kanyang panggagalingan ng outbreak to the point na magkakaroon na ng local transmission and then later sustained transmission na pag sobrang maraming chains na nagkakabit-kabit na. Yep.
Exactly. And so we now come to our final piece. So this one, see, Ma'am Eva, I just added this recently. Let's say you are an LGU executive and you're faced with the decision of whether or not to lift the ECQ totally or partially. What type of data might help you to decide on this one? So notice in my version, all the links have different sorts of activity. So here they could probably be eating, be studying, having a massage, praying in a church or a temple. They could be attending a trial court. They could be shopping, they could be traveling to a bus stop, bus station, whatever. They could be going to a hospital for checkup. So we're saying here, give me everything containing all these activities, and then count. Just give me the count. So if you then export this into a CSV and do a total, the total would be 21,462 contacts. So I propose using the number of interactions as the metric. So remember, in this case, right, we showed everything, all the activity. Now, what happens if we take out eating? So we just remove eating. And then we run this. And so we will get this data. If we download it, the total interactions would result to 17,694, or a 17.5% reduction in total interactions. So this way, chief executives of local governments can use data to inform their judgment. If you close down churches, this is the effect on interaction. If you close down shopping centers, this is the effect on interaction. If you close down schools, this is the effect on interaction. So the chief executive has more or less an idea of the effect of his decisions on which types of industry to open or to close. And with that, I end my workshop. Open to Q&A.
Nice, thank you. Were you able to show yung sa location, if location-based naman ang titingnan natin? Kasi even if there is physical distancing, pwede ring may virus na yung tao, nagpunta siya sa grocery, for example, sino yung mga nandun after that,
Very
after
good.
to that area?
Okay. Dito sa existing command natin, we can say where P of, ano ba yung name ba yun? Ano ba yung property niya?
Location yata ang nilagay mo last time. I don't know with this.
Natin, Name ata, name. Equal Dagupeñas. So you can add filters. So this is the command to show all the interaction. Pero right now, like what you said, we want to limit it to a particular place. Pwede po. So yan na lang ang natitira. You can say and whatever another place. So this is very what are the other place like Villaflor Hospital and some other place. What were the other places that we saw? Let's say dalawa lang sila. So this is the pattern. Remember that this is a graph analytics tool. So it looks for patterns. And guess what? In epidemiology, we are also looking for patterns. So
Yes.
here it's saying na walang ganon, no match. We can say or wala pa ring match. Ayan, meron ng matches. So we give you a set of initial templates, and over time, the users will know to mix and match.
Can we change yung or determine if kunwari a certain highly mobile person becomes infected, like yung situation kanina, and then hindi pa siya case, pero eventually naging case siya.
Yes.
That can be put into the program so that we can determine yung status and kung ano yung mga possible contacts that needed to be identified and yung seek out ng ating mga officials for the contact tracing. So if naging positive siya, or kung ano man yung change in status niya, pwede natin malaman ba yun from the program?
Yes po. Ito po. Same format pero yung ating filter imbis na P which is the variable for place, ginamit po natin N which is the variable for the person, the first person we're looking at whose user ID is 53. Nandito na. Ito na. Ito na si PH. So here is all the places and people the PH53 came in contact with. Sorry, hindi pala sa wala. It took a time for them to generate all of this. So
Compute, okay.
So he went to all these places. Kasi nga 53 when we generated had the highest degree centrality. So gala itong taong ito at very popular itong taong ito kaya marami siyang nakahalubilo. Super spreader ito.
Oo. Yung ganitong case, if we know kung ano yung kanyang status and then ito na yung mga contacts niya, close contacts niya, anong distance na ito yung ginamit natin? 1 meter, 2 meters, or just parang casual contact lang na nagkalapit lang sila by how many meters or feet?
Very good question, Doc Troy. So according to they're using Bluetooth. So maximum ng Bluetooth is 30 feet. Usually is between 5 to 10 feet. Magti-trigger yan ng contact record.
Okay na yun kasi at least meron tayong certain allowance pero at least we can already have that kind of idea na pwedeng maging possible contact siya, which is better. Parang more sensitive. Yeah.
It has been a very good and productive meeting. May I ask our President of the Philippine Society of Public Health Physicians, Dr. Lester Heroy, to close this session.
Thank you, Ma'am Eileen. Thank you, Sir Wilson. Thank you, Colonel Espina, Ma'am May of the ICT, Sir Troy, and to everybody who joined. This is a very interesting discussion, and we are very enlightened, especially from the ICT, the concerns on data privacy, backend, and so on. So parang I see it more of as different levels actually of work and coordination. So Viber communication or Slack would be great as way forward. Kasi there's a national level kind of coordination, including parang clearances, and regional level as well, and LGU level, including how LGUs can actually operate it, ano yung mga resources that they need, including in the end, Android or smartphones and so on. So yeah, thanks a lot. And on behalf of the team, thank you, Ma'am Eileen, also for moderating, and Dr. Troy. Thanks to all our colleagues, the regions, the DOH, and great to see and hear from you all. Thank you.